Hi there, my name is Jose Alejandro Lemus Vega, and now I am presenting my demo about the code of DDoS attack detection. So now we start importing all the libraries and packages that we need for this. And we use NumPy, Pandas, Matplotlib, Seaborn, LightGVM, JobLib, and Ton. Up there, here we upload the dataset. It is called Friday Working Hours.csv. Then we have a quick look when we click on head. When we type on head, we will see here all the dataset. Yeah. Then we start cleaning and removing spaces. We drop some of the columns features that we won't use to reduce the weight of the file. Then we have here we label. We have the label at the end, which is benign or DDoS. Yeah, and then we set for the benign one, and for when it's a mulling, when it's a DDoS attack, 0. Then we have here, and as we can see here, one. Yeah. Then after that, we check if we still have null data, something like that. After that, we check here what protocols do we have along the data set. So we have 6 and 17. That means that it's TCP and UDP. And we can see here, we can see the chart. Yeah. After that, we have here some preprocessing, mm, that is the label, to remove the label. Then after that, we have some adjustments here. We create an Instagram about all the charts that we have here on the dataset, or the features that we have. And here we can have all the information, all the charts that we generate, yeah, along all the data set. Yeah. Then after that, we go here on the data splitting. We start working on this. Yeah. And then we create a definition, function, sorry, a function of the columns if total forward packets are exist and the flow duration. Then we can start creating new features that we gonna use for our dataset. Then after that, we create the selector. We use a nova f value as a scoring function. Then we train this. We train this, and after that, while we train, we use some selector selected features, the features that we gonna take, because from of all of the features that we have, we're gonna choose some in a specific. And we say to the code, we say to the when we train these, which ones are we gonna use. So the ones that we're gonna use is destination port, protocol, uh, all of these, packet len max, packet len mean, and here we can find them. Then we move to the random forest model, and over here we have some parameters, number of estimators, max depth, some information, some um, options that we choose here, we set here. After here, we set all the parameters, and over here on the evaluation model, I choose some information as accuracy, precision, recall, F1 score, AUC, in order to see how is the when we train the model on random forest, and we get here 0.99, 0.99, 1 for recall, F1 score 0.99, and then for this model it took for to get trained it took 2 minutes and 15 seconds. Then after that we create a confusion matrix about this, and then we have 25,465 for uh, DDoS, and then 19,646 for benign um, data. Then for SVM, we do the same. We set some parameters, as C, uniform, and kernel. We have some here, linear, RBF, or poly. And then for the gamma, we set the scale or auto. Yeah. And the degree, it's between 2 and 5. Then for here, we do the same. We choose the best SVM model, and then it takes some time to get this. After the information, after, okay, then over here, after the information we set here, we get the best hyperparameters for SVM, and we set also as well accuracy, precision, recall, F1 score, and AUC, and then we set the time. How much time does it take to get this? After we get these information, the results here, and then for this one, it took 62 minutes and 23 seconds. Uh, we tried to get less time, but unfortunately, we got this, and this is the longest time on this model that took. After this, we create that confusion matrix for this one, and it gets same values, like around same values as before with the random forest. I know that the time used here it's huge, way huge, but then when we do the predictions, it doesn't take that time. It's just for the training. Then after this, we get gradient boosting machines, and over here we set the accuracy as well, and then the time, and then for this, we get the information here 99%, and then on the recall it just goes down 0.97, then 98, 98, and then this one it took 5 seconds to get trained. This is the quickest model that it took along all the models. And then we get the confusion matrix. And then on the confusion matrix, we get 25,500. And then for Benning, we get 19,238. And then for KNN, yeah, we set the same parameters here, and then we get almost same time, same information about 99%, 99%, as we see here. Also, we said the time was 1 minute and 4 seconds. And the confusion matrix, it gets like the same uh, numbers, 25,497, and then 19,633. We export all these models for each ones, yeah, and then after exporting we load them, and then we predict the models after training. After this, we predict the models, and then for the random forest it took 362 milliseconds. Then for support vector machine model we got 290 milliseconds. Then for the gradient boosting machine we get 266 76 milliseconds, we can see over here. And then the k nearest neighbor we got 1 minute 9 seconds and 204 milliseconds. For this one, k nearest neighbor it took a longer. And along all these, the four of models, I can assure that the quickest was gradient boosting machine. Yeah. And all the four of them they high accuracy. Unfortunately, unfortunately for the K nearest neighbor, it took 1 minute 9 seconds and 204 milliseconds, which which is the one that took longer along the four models. Yeah. Despite that, it has the four of them they have high accuracy. And also we can see here the information about accuracy precision that we got on each ones. And yeah, so thank you.